Okay, so we are going to begin with the objective question for chapter 2 for semester 2. Okay, so starts with question number 1. Below are the standard electrode potential at 298 Kelvin for several copper and iron ions. So you have Cu2 plus Cu at positive 0.15. You have Cu2 plus Cu2 plus Cu at positive 0.34, Cu plus Cu positive 0.52, Fe2 plus Fe negative 0.44, Fe3 plus Fe negative 0.04, and Fe3 plus to Fe2 plus positive 0.77. So the way of how they write usually is in the reduction form as per standard electrode potential. Okay, so based on the information, which of the following are incorrect? So please take notes in here. We are looking for the incorrect answer in here. So we are looking for the wrong one. Okay, so let's together deduce one by one. Number 1, copper is the strongest reducing agent. So how do we look for the strongest reducing agent? We look for the least most negative. Then we look at the species at the right. Okay, so the most negative is 0.44. Species as the right is iron. Okay, so iron is the strongest reducing agent. So 1 is wrong. Okay. Then number 2, iron 3 ion is the strongest oxidizing agent. So we look for the most positive value. Okay, so positive 0.77, yes. Fe3 plus, yes. So number 2 is correct, so which is not the answer. Number 3, copper 2 ion is able to oxidize iron 2 to become iron 3. So there are 2 ways in here, because we can look from 2 angles. Either we look from the angle of Cu2 plus to Cu, and then Cu2 plus to Cu plus. Okay, so you do both of them. Okay, so in here, if you compare between Cu2 plus to Cu2 plus to Fe2 plus, so in other words, in here you have to reverse. Do you understand or not? In another word, you compare Cu2 plus to Cu positive 0.15, then Fe2 plus oxidize to become Fe3 plus. So negative 0.77. So this one you reverse already you reverse because you want to oxidize. And then you compare another one which is Cu2 plus to Cu plus. So this is Cu plus. Cu plus to Cu positive 0.34. And then Fe2 plus to Fe3 plus negative 0.77. So both of them, E0 cell is negative, if you notice carefully. So as a result in here, so copper 2 plus cannot oxidize iron 2 to iron 3. So 3 is wrong also. Okay. And lastly, iron 3, the reaction of Fe3 plus, 3 Fe2 plus to Fe3 plus Fe is a spontaneous. So you compare between which reaction and which reaction. You compare this one, Fe2 plus to Fe, and also Fe2 plus to Fe3 plus. So in here, when you solve accordingly, I write the overall equation so that you can see clearly on what we are discussing here. So it's Fe2 plus 3 minus give Fe. E0 is negative 0.44. And then Fe2 plus give Fe3 plus E minus. So negative 0.77. Okay, so as a result, this one, the whole thing multiplied by 2. So in here, we shall have 3 Fe2 plus, give 2 Fe3 plus Fe. And the E0 cell in here is negative 1.21. Okay, so E0 cell is negative, reaction is non-spontaneous. Okay, so so the best answer in here is 1, 3, and 4. Okay. Okay, so that is for question number 1. Okay, so immediately we go to question number 2, shall we? Okay, so standard electrode potentials of the copper and silver are given below. Cu2 plus 3 minus gives Cu Ag plus E minus give Ag. E0 is positive 0.8. So following setup of obtained until pure copper by electrolysis as shown below. So you have copper argentum alloy or copper silver alloy, which is the negative terminal. Sorry, positive terminal. And then pure copper is the negative terminal. So when a current of 20.0 ampere flow through the electrolytes of copper 2 ion for 27 minutes, the mass of the anode decreased by 13.2 gram. What is the percentage composition of copper in an alloy of copper silver? So in here, you have to eventually know that there are there are few reaction take place in here lah. So it's the equilibrium between copper and copper ion, and then silver, because this is the anode of the cell. Okay, because this is the anode of the cell. So in terms of anode, we choose the one which is the least positive to corrode first. So the one with the least positive to corrode first is copper. Okay, so you use the four-step methods. So Q equals to IT or 20 times 27 times 60. So Q equals to 32,400. Then you find the mole of electron. 32,400 divided by 9650, you get 0.3358 mole. So stoichiometrically, copper to copper 2 plus plus 3 minus. So mole of copper is 0.03358 divided by 2, you get 0.167. So mass of copper is multiplied by 63.5, so you get 10.66 gram. So the percentage of copper in the alloy is 10.66 divided by 13.2 to 100%, you get 80% in here. So teacher, why is it that the copper is selected instead of silver? Because we are looking at anode. So anode, we are choosing the one which is the less positive. So the less positive will be first oxidized, isn't it? So copper will be oxidized to become copper 2 plus before silver do. So in the whole alloy, so copper will be first removed, only then silver will be removed. Understand? Okay, so that is why we calculate for the case of copper, and we found out that the percentage is 80% in here. So that is how we determine the percentage of the purity of copper in the samples. Then number 3, the following diagram shows the arrangement of the electrochemical cell, where you have iron, which act as an anode, and then metal M, which act as a cathode. So this is iron, and this is the deposit metal of M. Okay. So using relevant information in the data booklet, which of the following electropotential could be M, N plus, and M? So you want the inert cell to be positive, okay? So given to you, the standard electropotential of iron is Fe2 plus 2E minus, give Fe. E naught is equals to negative 0.44 and you want it to become anode. Anode means that it has to undergo oxidation. So Fe give Fe2 plus 2E minus. E naught is equals to positive 0.44. So anything that is less positive than iron can be eventually complete the cell. Okay, so I repeat, anything that is less positive than iron, eventually this one makes the cell become spontaneous. That means zinc is negative 0.76. So zinc cannot. Copper positive 0.34 can. Lead positive negative 0.14 can. And then, sorry, 0.13. 0.13, and then tin 0.14 also can. As long as you have the value lower than positive 0.44, all of them can eventually complete the chemical cell and show a spontaneous reactions. Okay, so the answer is 2, 3, and 4. So the answer is donkey D. Then we go to question number 4. Standard hydrogen electrode is shown below. So this is the hydrogen. Which of the following statement is true about standard hydrogen electrode? A. Sulfuric acid 1.0 mole is used as electrolyte, which is incorrect because you produce 2 mole of acids, H plus. Okay, so electrode used is palladium. It's not palladium, it's platinum, not palladium. Okay, coated on the surface. And then C, standard temperature pressure is applied. Now, there is a difference between the terms standard temperature and standard condition. Standard temperature pressure is 0 degrees Celsius, 1 atmosphere. Okay, standard condition is only 298 Kelvin or 25 degrees Celsius, 1 atmosphere. So C is wrong. And E naught value for the standard hydrogen electrode is 0 volt, which is correct. Okay, so that is for question number 4. Immediately we go to question number 5. Electrolysis process is an important application in the extraction of electropositive metal, which is true regarding to the electrolysis process. A. Oxidation occurs at cathode while reduction occurs at anode, which is wrong. Electron flow from cathode to anode through the external circuit, which is also wrong because electron flow from anode to cathode. Metal ion discharge to form metal at the anode of the cell usually is the other way around. Okay, so at anode, so you have metal to discharge to give metal ion plus electron. So metal is discharged at anode, so C is incorrect. So the amount of the metal discharge is directly proportional to the current supplied to the cell. So this is according to the Faraday's first law. Okay, so which says that the amount of the substance discharge is directly proportional to the quantity of charge. Okay, so the best answer in here is donkey D. Then we go to number 6. Aluminium has external oxide layer prevent from corrosion. The oxide layer can be increased by what? So this is a very technical question where there is only one way to increase the oxide layer of the aluminium, which is to equip aluminium in an electrolytic cell with the sulfuric acid. So we call it as an anodization. Anodization. So the best answer in here is C. Then we go to question number 7. Which of the following pair is used in industry to produce chlorine via electrolysis? So you use platinum anode and dilute sodium chloride. So you cannot have dilute you must have concentrated So in the diaphragm cell, anode is titanium, graphite is the cathode. So brine, which is the concentrated sodium hydroxide, is used as the electrolyte of the cell. So the complete set which we're supposed to produce the chlorine in here is donkey D. Titanium anode and concentrated sodium hydroxide. Sodium chloride, sorry. A. Diagram of Daniel cell is shown below. This is between zinc and silver. Which of the following statement is true about the cell? So you must know by yourself that you can check from the standard electrode potential that Zn2 plus Zn E naught is equals to negative 0.76 volt and then silver Ag plus Ag, so E naught is equals to positive 0.80 So this will make the zinc to become the anode, silver to become the cathode of the cell. Okay, so which of the following is true about the cell? Number 1, it says that the zinc ion attracted to the zinc electrode, which is not true. Okay, so zinc ion will eventually goes to the direction of the cathode, okay, which is the silver plate. Okay, and number B, silver ion will attracted to the zinc electrode. So silver ion will eventually attracted to the cathode. So the rule is like this: anion attracted to anode, cation attracted to cathode. Okay, so if zinc ion positive zinc ion cation will goes to cathode silver plate. Silver ion, which is the cation, attracted to silver plate also. Okay, because cation attracted to cathode. And then K plus attracted to the silver electrode. So K plus is the cation attracted to the cathode, correct? And then nitrate ion, which is the anode. Anion attract to anode, which is the silver zinc plate, so which is wrong. So the best answer in here is C. Okay, so teacher, where does the K plus come from? K plus come from the salt bridge in here. Okay, so the best answer in here is C. Okay, then we go to number 9. Molten compound consists of element A and B, is electrolyzed using a 2.00 current ampere, 965 seconds. 2.07 gram of A is formed at cathode, while 488 gram of B is formed at anode 25 degrees Celsius. Which of the following is the empirical formula of the compound involved? So you use the 4-step method to calculate the mole of the electrons involved. Okay, so mole of A is 2.07 divided by 207, you get 0.01 mole, while mole of B is 488 divided by 24,400, they are 0.02. So mole of B2 we are going to say is B2 okay, because B2 is a diatomic molecule as mentioned inside the question, B2 gas. Okay, so since the empirical formula of A to B2 is 0.01 to 0.02, that means A to B is 0.01 to 0.02 times 2. So empirical formula therefore is AB4. Okay, so that is how we determine the empirical formula in this case. Okay, okay, so that is for question number 9. Then we go to question number 10. In the presence of the catalyst, the peroxyl disulfate ions S2OH2 minus oxidized iodide ion according to the equation S2OH2 minus plus 2I minus give 2SO4 2 minus plus I2. So given the standard electrode potential are the following. Okay, so which of the following ions suitable act as a catalyst? So in other words, in here we are going to choose the one inside this 4 when you are able to oxidize, reduce, S2082 minus to become SO4, and then at the same time oxidize I2 to become I minus. So in order to become the catalyst for the reaction, so to oxidize I minus to become I2, okay, so E naught must be more positive or less negative than 0.54. That means must be more positive, must be more positive, okay. While to reduce S2082 minus to SO42 minus, the E naught value must be less positive or more negative than 2.08. Okay, so we are looking for E naught value more positive than 0.54 for I minus. Okay, so inside here, the one that works well is manganese. Okay, manganese and also iron. Okay, because copper when you because eventually you need to reverse the I minus to become I2 because now these all are written in reduction form, isn't it? So reoxidize, that means you need to reverse, so the magnitude will be negative. So if you want your E naught cell to be positive, your the other half cell must be greater than negative 0.54. Okay, so in another word, copper 2 plus to copper cannot, chromium 3 plus to chromium also cannot. Okay, and then finally for S2OH2 minus to become SO4, any value lesser than 2.28 all are accepted. So it seems that all of them are lesser than 2.28. So the best answer in here is 1 and also 4. Okay, 1 and 4. MnO4 minus and Fe3 plus. Okay, so the best answer in here is B. Okay, so that is what's going on in here. Okay, number 11. An aqueous solution of the nitrate of a metal X is electrolyzed using metal X as the pure electrode of A and B. So this is metal X electrode A, metal X electrode B. So aqueous solution of nitrate X. So when a 0.49 ampere of the current is passed through the electrolyte for 2000 seconds, the mass of the cathode increased by 0.325 gram. Which of the following statements are correct with regard of the electrolysis? Given to you, reactive atomic mass is 64.0 and 1 Faraday is 96,500 coulomb per mole electron. A total of 0.49 times 2.0 times 10 power of 3 over 96,500 Faraday is passed through the electrolyte. So in here, our Q equals to IT okay? So 0.49 times 2,000 times 10 power of 3, okay, divided by 96,500 Okay, so number 1 is correct. So the formula is correct. Okay, then mass of A decreased by 0.35. So as for the metal of A and B are pure metals, okay, so therefore the decrease in the mass of A, which is 0.325, indicates that the increase in mass of B, which is also 0.325. So the mole of X deposited in here will be negative 0.325 divided by 64, you get 0.005078 mole. Okay, so in another word, the number of Faraday constants required in here to deposit 1 mole of electron. So it's 0.1015 divided by 0.05078 is 2 Faraday. So therefore, the charge of the ion is +2. Okay. So you compare step 1 and step 3. Okay, step 1 and step 3. So as a result, the equation goes like this: x2 plus 3 minus x. Okay. Okay. In here, so the half equation is B is correct. Okay. And finally, solution of the changes is concentration. In here, the concentration do not change much because it only involves the transfer of the ions. So usually in the electrolysis process, concentration will remain almost the same in here. Okay. So number 4 is incorrect. So the best answer in here is 1, 2, and 3. Okay. So hopefully you can understand what I'm trying to deliver in here. Okay. If you cannot understand, you can always raise your questions. Open your mic and raise your questions. Okay, so this is for number 11. Okay, then we go to question number 12. The graph below shows an electrode potential of the half cell for the reaction of WXYZ from the same group. The keyword is from the same group. And if you notice carefully, they are all negative. Negative usually indicates that they are all metal. Okay, they are all metal. Okay, and the metal in here from W to Z, you notice that the value become less negative. So it means that from in the case of the periodic table, let's say if you have a periodic table, okay, let's say group 1 or group 2, isn't it? Okay, if you still remember well, the E naught value when going down to all the group of metal will increasingly positive, increasingly negative. Okay, increasingly negative. So in this case, they are now showing from W to Z is decreasingly negative. So the traits will go the other way around. Okay, in this case, the traits will go the other way around, will go up of the periodic table. Okay, so therefore, based on the graph, we can be conclude that from W to Z, so chemical reactivity of element increase. So number A is wrong, so it's decrease because E naught value become less negative. If electronegativity of the element decrease, so as going up to the periodic table, electronegativity increase. Okay, because when going down to the group, electronegativity decrease. When going up to the group, electronegativity increase. Okay, so B is also wrong. Strength of the element as reducing agent increase, which is also wrong. So when you have less negative, it becomes a less stronger reducing agent. Okay. And finally, D, melting point of the element increased. So which is true, because when going up, the melting point will usually increase for metals. Okay. So the one with the higher position will have a higher melting point. Okay. So that is for D. Okay, so that is for number 12. Then immediately we go to the next one, which is number 13, shall we? Okay, number 13 sounds like this. The standard electrode potential for the some half cells are given below. So you have chlorine positive 0.136, silver ion silver positive 0.8, Fe3 plus Fe2 plus 0.77, and I2 to I minus positive 0.54. Based on the data above, which of the pair of species can react with each other? So in other words, which one is spontaneous? So if you look carefully when you compare to each other, for number 1, okay, so E naught cell in here, you compare Cl2 to Fe2 plus. So is I use 4 different colors, so you can see clearly. Okay, so is Cl2 to Fe2 plus. So eventually this one will be reversed. It will become negative. Okay, isn't it? It will become negative. Okay, so positive 1.36 minus positive 0.77, you get 0.59, which is spontaneous. Okay, then you compare number 2, I2 to Ag. So I2 is here, Ag is here. So positive 0.54 plus negative 0.8. So E naught cell will be negative 0.26. So the reaction is non-spontaneous. So number 2 will not react. Number 3, Fe3 plus and Cl minus. So Fe3 plus is this one. Cl minus is this one. So we reverse the Cl minus. So it becomes negative 1.36 plus positive 0.77. So eventually the E naught cell will be negative also. So the reaction is non-spontaneous. And finally, silver plus, okay, silver plus and also I minus, okay, I minus. So you have positive 0.8 plus negative 0.54. So you get positive 0.26. So the reaction is spontaneous. Okay, so the best answer in here is 1 and 4. So the answer is point B. Okay, so that is how you compare the E naught values in here. Immediately it goes to number 14. Standard electrode potential of the E naught for oxygen and dichromate are shown below. So 2H plus O2 plus 2E minus gives H2O2. E naught is positive 0.68. Cl2O72 minus plus 40H plus 60 minus 2 Cl3 plus. E naught is positive 1.33. Based on the information above, which of the following is true of the chemical cell that is made from connecting the half cell under standard condition? Okay, so here A, H2O2 undergoes oxidation to form O2. So you compare, you reverse this equation. So when you reverse it, you become negative. So the reaction is still spontaneous. So A is correct. Okay. B, H2O2 is a stronger oxidizing agent compared to Cl2O7, which is wrong because H2O2 is you cannot compare because H2O2 is at the right side. So you cannot compare in terms of oxidizing agent. So number 2 is wrong. Number 3, electromotive forces of the cell is positive 0.21. So no, you have to reverse the first equations. So you get a positive 1.33 but minus positive 0.68, so you get positive 0.65. So C is wrong. And then D, the cell diagram is written as PtCl2O72 minus Cl3 plus. That means chromium will undergoes oxidation, and then H2O2 will undergoes reduction. Because always remember, when we write the standard cell diagram, everything at the left side is for oxidation, everything at the right side is for reduction. So D is not correct. So the correct way to be written as O2, H2O2 double line, Cl2O7 to Cl3 plus. So the D is also incorrect. So the best answer in here will be A. Okay. Okay, so that is for how you solve question number 14. Then question number 15, the relationship between electropotential and the ion concentration is given by the Nernst equation, where E cell equals to E log cell plus 0.059 over N log reduced species over oxidized species. So given the standard electropotential of the Cu plus 2Ag plus gives Cu2 plus 2Ag is positive 0.46. If concentration of silver ion is reduced to 0.1, concentration of Cu2 plus is maintained, what is the E cell of the above cell changes? So in here, you have to apply the Nernst equation. So E cell equals to A naught cell plus 0.059 over N log. In this case, if you use positive, positive will be reactant over product. So you have Ag plus over Cu2 plus. Okay, so you have positive 0.46 plus positive 0.59 divided by 2 electron, log 0.10 square over 1. Okay, so you get E cell equals to positive 4.01. So the best answer in here will be B. Okay. Okay, so that is for question number 15. Then we go to question number 16. The EMF of the cell of the standard condition is shown below. We have Zn2 plus, Ag plus, Ag is 1.36. PtH2H plus to Ag is positive 0.8. And then Zn2 plus Zn plus Pb is positive 0.62. So what is the value of the standard reduction potential of the Pb2 plus? So in here, there are two ways. You can use the cancelling of each other technique to this one. So you try to get into the position where Pb2 plus, Pb2 plus is the oxidizing agent, while H plus H2 is the, act as the Pb2 plus is the at the left side, H plus H2 is at the right side in here. But I know, okay, so this is an unorthodox method. Of course, this is not the best. Later, I show you a better one. Okay, so you can eventually cancel zinc 2 plus with zinc 2 plus, silver with silver. So at the end, you get PbH plus H2. So you sum up everything. So when you sum up everything, you get positive negative 0.14. Okay. You do it like Hess law methods. Okay. Another alternative way that you can do is like this. Let's say between Zn2 plus Zn, so you have positive 1.36. Okay. So because Zn is at the left side, zinc is higher. So Zn 2 plus Zn. So Ag plus Ag. This one is the method that you use in the Stpm. I find it quite useful. Maybe you can understand better. 1.36. Okay, then PtH2Ag. So Ag is still at the left side. So you make it at the low end. When Ag plus Ag is at the left side, that means Ag is lower. So you get 0.8. Okay, so this is 0.8. And then last but not least, Zn2 plus Pb is 0.62. Okay, this is between Ag. This is still at the same level. You maintain at the same level. And then this is H plus, H plus H2 slash H plus. Okay, okay. And then last but not least is where you have Zn and Pb2 plus. So Zn and Pb2 plus, you have you maintain the level. Okay, so is positive 0.62 lah. Sorry, yeah. Positive 0.62 in here. Okay, so here is it. Positive 0.62. So this is for Pb2 plus Pb. So in here, you can see that lead has a higher position than hydrogen. So in other words, the E0 value for the lead will be negative. Okay, so that is how you get the E0 cell equals to negative 0.14 in here. Okay. Okay, so that is how we are going to solve for this question. So either way, they can be obtain your answer. Okay. Okay, then you have number 17. Standard reduction potential of the 3 half cell are given as follow. FeO4 2 minus plus 8H plus 3 minus give Fe3 plus 4H2O. E0 is positive 2.20. Mn2 plus Mn H2O positive 1.52. Ni2 plus Ni is negative 0.25. Which of the following statement is or are true? Number 1, higher oxidation state of a species, stronger is oxidizing power. So you have to calculate one by one. So Mn is positive 7, plus 7, plus 7. And then iron is plus 6. Okay. And then Ni is plus 2. So this one is not true because Fe is still the most negative. Okay. And sorry, most positive. So nothing to do with the high oxidizing agent. Okay, and then number 2, the reaction between acidic MnO4 and nickel is spontaneous. So you compare this one to this one. So positive 1.52 minus 0.25, you get positive 1.77, which is spontaneous. B is correct. And then FeO4 2 minus is a stronger oxidizing agent than MnO4. Yes, because it is more positive. So 3 is correct. And then number 4, EMF of the cell between FeO4 and Mn2 plus is positive 0.68. So you reverse the 1.52, so you get 0.68. Okay, so 4 is also correct. So the best answer is 2, 3, and 4. Okay, then we go for question number 18. The respective electrolyte for 3 electrolytic cells are aqueous sodium hydroxide, concentrated hydrosodium chloride, and aqueous silver nitrate, for each of the carbon electrode connected to the series. What is the ratio number of mole for hydrogen gas in the first cell, chlorine gas in the second shell, and oxygen in the third shell when electrical current is flowed through in the 3 cells? So because they share the same current, so the number of mole of electron is supposedly to be the same. So in here, for the first one is the electrolysis of water at the cathode. So 2H2O plus 3 minus give H2 plus 2OH minus. While at the second cell, 2Cl minus gives Cl2 plus 2E minus. So mole of electron is 2. So for 2H2O plus O2 plus 4E minus give 4OH, 4H plus. So you get 4 electrons. So when you try to mix the whole thing become the same. So eventually you notice that the whole thing in here you need to multiply by 2. Okay, times 2. This one also times 2, so that the number of electrons will be the same. So the stoichiometric gas is become 2 to 2 to 1. Okay, so the simplest ratio therefore is 2 to 2 to 1. Okay, so the answer is longevity. Okay, so that is how you are going to answer for question number 18. Then we go to question number 19. Okay, this is a very tough question. In the anodization, the anode of the aluminum object and the reaction that occur follow. 4OH minus give O2 plus 2H2O plus 4E minus, so 4Al plus 3O2 plus 2LO3. If the aluminium subject have a surface of 5.0 times 10 power of 2 centimeters cube square, how many column of electricity are needed to increase the thickness by times 10 power of 3? Okay, so I hope that you can understand. So initially, you have the surface area is 5.0 times 10 power of 2. Okay, so now this whole surface area, you are going to increase with an oxide layer, increase the thickness by 1.0 times 10 power of 3. Okay, you have this one 5.0 times 10 power of 2. Then you want to increase the layer by 1.0 times 10 power of negative 3. So the total area in here, you multiply. Okay, so that will be the volume required in here. Okay. So from the volume, because centimeter cube times centimeter square times centimeter, you get centimeter cube. Then you divide by the you divide by the density to get the mass. Okay. Then you'll be able to figure out. So here are the solved methods. So volume of the Al2O3 deposited is 5.0 times 10 power of 2 times 1.0 times 10 power of negative 3. So you get the volume is 5.0 times 10 power of negative 1 centimeter cube. So from the density, you can get the mass of aluminum oxide. So density times volume, so 40 times 5.0 times 10 power of negative 1, you get 2 grams. So anode, the half equation in here is 2OH minus give O2 plus 4H plus 4E minus. Okay, I'm going to use the equation in here. Sorry for that. But more or less the same. Sorry for that. Because I used the wrong equation. It's 4OH minus give O2 plus 2H2O plus 4E minus. Okay, so you have to mix the electrons eventually become the same. Okay, so eventually the whole equation in here you multiply by 3 so that you can get the mole of the electron is equals to 12. So in here 12 electron is equals to 2 Al2O3. So 1 Al2O3 is equivalent to 6 electron. Okay, so in here the 1.102 is the RMM of the aluminum oxide. So you require 3 times 2 times 4 Faradays. So 2 grams of aluminum oxide require 3/2 times 4 times the Faraday constant, 96,500, multiplied by 2 divided by the RMM. So you get 1.1 times 10 power of 4 columns. Okay, so the best answer in here will be C. Okay, now I know that it's a little bit complicated in here, and I'm so sorry I didn't summarize in the form of the equations, but I hope that the solutions in here are enough to make you understand how do I get to my final answer in here. Okay, so that will be all for until today. So we stop at number 19, then we continue in our next lesson for 20 until 40 objective. So that's all for our lesson today. So see you all in our next lesson. Okay, goodbye.
Thank you, Mr. Chu.
Welcome.